Exercise 16C, average rate of change. In the previous exercise, we were talking about a constant rate of change, and would you believe it's exactly the same as saying an average rate of change? The only difference is that between the two is, in terms of its calculation and things like that, is that we can sometimes calculate the average rate even if there's a bit of a curve going on. A constant rate of change implies that the graph is a straight line. So what do I mean by that? Calculating an average rate of change is when I've got some scenario where there are some different rates of change going on, and I have been asked to calculate, on average, how much is a graph change between 2 points. So for example, you might have a big old squiggle like this, and you might be asked to calculate the rate of change between here and here. So when we calculate the average rate of change between here and here, what we do is we pretend there is a straight line that's connecting the two. And then we get our coordinates A, B, C, D, and we can go and find the average rate by doing D take away B over C take away A, or the classic y2 minus y1 over x2 minus x1. This is a useful guide to being able to see if approximately how much has a graph changed. What we will eventually like to try to do is to try to see if we can find a rate of change for the smallest possible distance, or what we call an instantaneous rate of change, but we'll cross that bridge when we get to it. For each function, find the average rate of change over the stated interval. So to do this, we need to do our y2 minus y1 over x2 minus x1. We've got a couple of x's, the 0 and the 3, but we haven't got the y's. So we better find out what they are. So for A, better find out what f of 0 is. In other words, all I have to do is just replace the letter x with a 0. 2 times 0 is not 2, it is 0. 0 plus 3 is 3. So we've got our first coordinate, 0, 3. And then for f of 3, 2, 3 plus 3, 2 times 3 is 6. 6 plus 3 is 9. So therefore, we have got our next coordinate, 3, 9. So the average rate of change for this one is going to be 9 take away 3 over 3 take away 0. 9 take away 3 is 6. 3 take away 0 is 3. 6 divided by 3 is 2. Now, I know that this is correct, and it's not because I'm a big old smug, clever teacher, because I promise I'm not. I'm just a fraud in a suit. But in that particular equation there, that is a linear equation. And the linear, if you vaguely remember about linear graphs, the number next to the x, as in this fella, right here, that tells you the gradient. And the gradient is going to be the same rate of change for the entirety of the graph. So this is the rate of change, no matter how average you make it. It means at any point on the graph, the rate of change is going to be 2. So we know we are definitely correct. Huzzah! So instead of all that calculating, it could have just gone, oh, there it is, 2. So that's fine. Now, C, unfortunately, I can't do that because this one, as you might have gathered, with this 2 over x minus 3 plus 4, this is from chapter 4, this one. This is a big old hyperbola. And as a reminder of what this hyperbola looks like, it's going to be looking something like this. It's been moved up by 4, so it's going to look something like this, friend. Yeah, so it's going to look something like this. And we want between 4 and 7. Now, so it's going to be, because where's that asymptote? That asymptote is at x equals 3. That's at y equals 4. So we're wanting to see a rate of change here. Now, you didn't have to draw the graph, but it is very useful if you are double sort of guessing yourself. Now, I know it's on that section of the graph, so that means it's sloping down, so my average rate of change should be a negative number. If I'm not getting a negative number, something has incredibly gone wrong. So let's go and have a look. So it's m is equal to y2 minus y1 over x2 minus x1. So I better go and substitute some fellas in there. So f of 4 is equal to 2 over 4 take away 3 plus 4. So this is 2 over 1 plus 4. So that's going to get me 6. and then f of 7. So the first coordinate is 4, 7. So I can do... So now it's time to go and do the division. So we've got 9 over 2, take away 7 over... what's the x values? 7 take away 4. So 9 over 2 take away 7. So 7 is going to be 14 over 2. So it's going to be negative 5 over 2 divided by 7 take away 4, which is equal to 3. So it'll be 3 over 1. So negative 5 over 2 times by a third. So that's going to be negative 5 sixths. So I definitely know that I'm right because it was supposed to be negative. Find the average rates of change of y with respect to x from point A to point B for the following graphs. Now I wanted to highlight this bit because it says rate of change of y with respect to x, and this throws off a lot of people. It's not as complicated as it looks. It's just a fancy way of saying the change in y divided by the change in x. That's all it is. So the rate of change of y with respect to the change in x, that's what has been dropped off there. It's just a very old-fashioned way of saying the gradient from point A to point B. So now the one thing I have neglected to say, and I probably should say it now before I get into all kinds of trouble with, proper maths teachers, is that when you do the rates of change and things like that, we do our y2 minus y1 over x2 minus x1. You'll notice that I've probably done the same ones. I've treated the ones on the left as x1, x2, and the ones on the right as x1 and y1, and the ones on the right as x2, y2. But it doesn't have to be. You can use the coordinates in any of those combinations, and I'm going to use this as my example. So I've gone from A to B, and I'm treating this as x1, y1, and this one is x2, y2. And I'm going to do 5 take away 30 over 2 take away negative 5. And that's going to be equal to negative 25 over 7. And I can leave that answer as is because it can't simplify. I will get the same answer if I swap the numbers around. So rather than the 5 and the 2 there, if I made that 30 take away 5, and I did negative 5 minus 2, I still get 25 over negative 7. And as you might be aware, if the negative is on the bottom, just from a simple writing point of view, we just chuck it at the top anyway. So it's still negative 25 over 7. So as long as you're consistent, as long as you don't mix up the coordinates from one to the other, and you call like x1 over here and and y2 is here or some nonsense like that, it doesn't matter which side you do. So I just wanted to clarify that here. This one, y2 minus y1 over x2 minus x1, it's going from here to here, so it should be a positive number. 15 take away 3 over 3 take away 0. It's going to be 12 over 3, which should be 4. Example 3. Alex puts $1,000 in the bank and accumulates interest of 4% of the initial investment per year for the first 5 years. Now, for those who are doing general maths or further mathematics, you'll know that this is an example of simple interest, which means it gets an extra amount of money per year, and it's the same amount of money. And in this case, it's 4% of the initial investment, which will be this $1,000. At the 5-year mark, new interest is calculated. 7% of the 5-year total is then added every year until the 10-year mark. And we're going to draw a graph that represents this information. Now, the scale of this graph is very annoying. So, this is going to seem very annoying, but I'm actually going to do a little table of values. That's what I'm going to do. So the initial investment is 1,000. So then it's 4% of that initial investment. So 4% of 1,000. The zeros can cancel down, and that's going to be 40. So it's $40 is getting added each time. So from this point on, from the 6-year point on, it's going to be 7% of that 1,200 is going to get added each time. So is it 7? Yeah, it's 7 of 12. So that's going to be $84 is being added each time. So then the question says calculate the average rate of change over the 10 years. So we've got 0 and 1,000 here, and this will be 10 and 1620. So the average rate, or M, is going to be 1620 take away 1,000 over 10 take away 0. So that's going to be 620 divided by 10, or otherwise $62 per year.